All right, so our goal is to find the highest, the lowest, the leftmost, and the rightmost points on this parametric function. So we got x of t is cosine 3t, and we got y of t is t squared minus t minus 1. So what do you guys think we should do first? Highest, lowest, or leftmost and rightmost? Left and right. All right, so we'll do the x of t values. Yeah. All right. Oh, here comes Brian. Brian's gonna make it just a couple minutes late. Good morning, Brian. You're late. All right. So if we're going from 0 to 2 pi here, and we want to find the leftmost and the rightmost, we need to look at our dx dt values and see when dx dt is at a minimum or a maximum, or when x is at a minimum or a maximum by using dx dt. So first, what is dx dt? Dx dt should be, oh good, you guys wrote it correctly in the chat, -3 sine 3t. And we're interested in when that equals 0 and when it's undefined. It's never undefined. So when does that equal 0? When the sine of 3t equals 0? True? And when does sine equal 0? When the angle is 0, when the angle is pi, and when the angle is 2 pi on the interval from 0 to 2 pi. So that should give us 3 values, Nick, right? Not just 2, right? Because when the angle is 0, when the angle is pi, and when the angle is 2 pi, those are all places where it's 0. So at t equals 0, t equals pi over 3, and t equals 2 pi over 3. Everybody good with that? What else? There should be some more of these, right? Because we should be adding on to each of these, right? Like at 0 plus, really this is what, 0 plus every pi n, isn't it? Right, if we were to keep going here, this would also be at 3 pi and at 4 pi and at 5 pi. And when we divide those by 3, that's going to give us a bunch more values. So we'll say also at pi, also at 4 pi over 3, also at 5 pi over 3, and also at 2 pi. Yeah? Good or no? Hopefully so. Can we make, if we wanted to, could we make a sign chart to see what's happening with our function and its x values in between 0 and 2 pi? We could, right? In fact, let's do that real quick just for fun. This isn't totally necessary. Now, we'll note that both of our endpoints, 0 and 2 pi, were included in our values that made our derivative of x equal to 0. So they're going to be on our sign chart anyway. But even if they hadn't been, we'd want to include those endpoint values and take a look at them. So the step that I'm doing here with the sign chart's not super important unless it's asking you, like, you know, when is it moving to the right, when is it moving to the left, etc. But we'll do it just now, just to, even though the question doesn't ask, just to, you know, just to see. So if I plug in something between 0 and pi over 3, that'd be like pi over 6 would work, right? And our derivative was -3 sine of 3t. So 3 times pi over 6 would be what? Pi over 2. Sine of pi over 2 is positive. Times a negative is negative. So we know that it's moving to the left from 0 to pi over 3. Then from pi over 3 to 2 pi over 3, something in between there would be like pi over 2. we get a 3 pi over 2 here. Sine of 3 pi over 2 is negative. Times a negative is a positive. Something between 2 pi over 3 and pi, like 5 pi over 6. When we multiply that by 3, that's 15 pi over 6, which is the same as pi over 2. So again, that's going to be negative. And you'll see as we go through here each time, it's going to just flip back and forth here. Everybody good with that? Won't bother plugging the rest of them in, but they definitely flip back and forth. So where could it be at its rightmost points? When it finishes moving to the right? When it finishes moving to the right. So it could be at 0, it could be at 2 pi over 3, and it could be at 4 pi over 3, and it could be at 2 pi. Well, let's see, what's the cosine of 0? Cosine of 0 is 1. And if we plug in 2 pi over 3 and multiply that by 3, that's just going to become cosine of 2 pi, which is also 1. I shouldn't have written that cosine of 2 pi over 3 is 1, but cosine of 3 times 2 pi over 3 is also 1. And what about the cosine of 4 pi over 3 times 3? It's also 1. And 2 pi over 3, 2 pi times 3 is also 1. So all of these values where it's going to the right and ending, they're all the same. They're all going to be values at which is at its rightmost point. Right? So it's got a bunch that are tied for the furthest right. And if it asks for the actual points, we need to plug in the values. So we'd say 1, comma, and then we plug in 0 there. So that'd give us -1. And I'm not going to evaluate each of these at like 2 pi over 3 just because of that being an annoying thing to plug in, but we'll just say y of 2 pi over 3. And we'll say 1, comma, y of 4 pi over 3. And also 1, comma, y of 2 pi. And these are the rightmost points. They're all tied for the furthest right. Everybody good with that? All right, what about our leftmost points? Leftmost when it's finished moving to the left, when the dx dt is done being negative, so that'd be at pi over 3 and at pi and at 5 pi over 3. Yeah, Molly, so you always test the endpoints no matter what, but also because the other reason is because that's a place where the derivative was equal to 0. Yeah, normally you need to plug the t's into y of t. Yes, Nick and Molly, does that make sense? 1, because it's an endpoint, and 2, because it's a place where the derivative is equal to 0. Okay. All right, so for our leftmost, I'm imagining you guys will agree with me that cosine of 3 times pi over 3 and the cosine of 3 times pi and the cosine of 3 times 5 pi over 3 are all going to be the same. So what's the cosine of pi? Cosine of pi is -1, right? So our leftmost points, those are all going to end up being the same. They'll be -1, comma, y of pi over 3 and -1, comma, y of pi and -1, comma, y of 5 pi over 3. Everybody good with leftmost and rightmost there? I know my work's a little bit chicken scratch there, but it's all over the place. It's a little bit of a mess, but hopefully that makes sense, yeah? All right, and what about the highest and the lowest points? So we had y of t was equal to what? T squared minus t minus 1, is that what it was? Yeah. So we need to figure out when that's at a max and when that's at a min. And so we will take a derivative of that, dy dt, should be equal to 2t minus 1, never undefined, but equal to 0 at t equals 1/2. So that's one option. And then the other options of where it could be at its lowest point and its highest point should be what other two t values. Starting point and endpoints, right? That's our endpoints of 0 and 2 pi. So when we make a sign chart, or when we just plug in these values, we'll make a sign chart. Here's 0, here's a half, and here's 2 pi. If I plug in something between 0 and a half, like a quarter, plug in a quarter to this, I get a negative. So my y values are decreasing as I go from 0 to a half. And then between a half and 2 pi, like let's say 1, then they're positive. So then those values are increasing. So it looks like my lowest point should be at 1/2. And our highest point should either be at 0 or at 2 pi. And we'll have to figure out which one of those is larger. So y of 1/2 equals what? 1/4 minus a half minus 1, which would be what? Negative 5/4. So that should be our lowest point. Our lowest point should be x of a half, or what was that? It was cosine of 3t, is that right? So cosine 3/2, comma, negative 5/4. And then our highest point will be whichever is larger of 0 and 2 pi. So what's y of 0? Y of 0 is negative 1. And y of 2 pi is 4 pi squared minus 2 pi minus 1. I would have to think that 4 pi squared minus 2 pi minus 1 is going to be quite a bit larger than negative 1 is, right? So our highest point ought to be the cosine of 3 times 2 pi, and that'd be the cosine of 6 pi. Cosine of 6 pi is the same as the cosine of 0, which would be an x value of 1, and then 4 pi squared minus 2 pi minus 1. Everybody good with that? Hopefully. So we've got the cosine of t and t squared minus t minus 1. And we're going from 0 to 2 pi. Everybody can see the graph now? I hope. Yeah. So we'll see that what this function is doing, or what this equation is doing, is here's its starting point at 0, which was at 1, and then I think it was 1, negative 1, right? It goes down ever so slightly there at the beginning. If you take a look, right, it goes down ever so slightly, hits that lowest point, then hits the leftmost point, then comes back, hits another rightmost point, then comes back, hits another leftmost point, back to another rightmost point, just like we saw, back to another leftmost point, and then finishes off at a rightmost point and its highest point. Good or no? I feel like that should be pretty straightforward. Any questions on that last one before we start the next one?
Thank you.
All right, why don't you guys give this one a try on your own? I'll give you a minute or two to work on it, and then we'll talk about it. Note that on one side, we don't have an endpoint, right? T is greater than 0, but less than or equal to 10. So we've only got one endpoint that we're dealing with. We're not dealing with an endpoint at t equals 0. So take a minute or two and see if you can figure this one out, and then we'll talk about it. The problem still there? Sorry, I don't know what happened. I muted myself to let you guys work on that problem, and then the second I clicked mute, it just dropped me from the meeting. So you can't see it. How about now? You guys see it now or no? All right. Think we should be good. I don't know what happened there. Sorry. Cool. All right. Take a minute or two and see if you can do this one. Almost finished with that one. I think that was a pretty easy one. You guys all still here? Can you hear me okay? Are you finished with this problem? I feel like this one was a pretty easy one, so. All right, let's talk about it real quick. We'll do left and rightmost first. So dx dt should just be 1 over t, which equals 0 never. And it's undefined at t equals 0. But we can ignore that because 0 is not involved in this equation because we can't have a t value of 0 because you can't take the natural log of 0. All right, so the only option for a highest or a lowest point would be at t equals 10. And you should be able to tell whether it's higher at something, if we make a sign chart between 0 and 10 and plug in something to the derivative, well, this is always going to be positive, so this should always be increasing. So we should see that our rightmost point should be at t equals 10. And then there should be no leftmost point because there's no endpoint to the left. And so the point that it's at its rightmost is natural log 10, comma, e to the 30th power. Everybody good with that? And then dy dt, which should be 3e to the 3t, that also never equals 0 and it's never undefined. So your only options are at the endpoint, which will be at t equals 10. And once again, we can do a sign chart here, 0 to 10, to see if the y values are getting larger or smaller. Put in a number between 0 and 10 that comes out to be positive, so the y values are increasing. So we have no lowest point, but the highest point ought to be the same thing, natural log of 10 e to the 30th. Okay, so make sure if there are endpoints, you check the endpoints. That's my only point with this particular problem. If there are endpoints, check them. If there are not endpoints, don't include them. Good or no? All right. All right, can you guys see this new problem here? Cool. All right, so we're going to go through just a few practice AP style questions that came from the College Board. I've just pulled all these that we're going to do now straight from College Board that are all related to some of the stuff we've been doing in the last week or so with the max and min stuff, or with parametric stuff, and a little bit with polar stuff. So I'm going to give you guys a minute or two on each one, and then we'll come back to it and go through it. So let's do that. Take just a minute or two, and then we'll go through this one. So first thing we have to do, we're looking for the critical points and the relative maxes and mins, is take a derivative. So if it's 2x e to the negative x, and we're looking for the derivative, we got to use which rule? Got to use the product rule. Good. So we'll do 2x times the derivative of e to the negative x, and e to the negative x requires the chain rule. So it's just e to the negative x times the derivative of negative x, which is -1, and then plus 2, which is the derivative of 2x e to the negative x. Everybody good with that? Okay. And what can we factor out? We can factor out a 2e to the negative x from that. So that leaves me with just a 1 from the second term, and then a minus x from the other term. Everybody good there? All right. So first off, when does that equal 0? Is 2e to the negative x ever going to equal 0? Yeah, that should never equal 0, but the 1 minus x will at x equals 1. And when is this undefined? 1 minus x can never be undefined, right? What about 2e to the negative x? Can 2e to the negative x ever be undefined? Nope. Right, you can plug any number in for x, take the negative of it, raise e to that power, and multiply by 2 for anything. It's never undefined. All right, good. So the only critical value that we've got is x equals 1. Okay. And so then we'll just make a sign chart here and make sure that you prove whether it's a max or min. Two different ways. One way is that we could make the sign chart. The other way is we could use the second derivative test, but the sign chart is probably a lot easier in this case. So plug in something, something greater than 1, like 1,000. E to the negative 1,000 is still a positive number, right? Times 2 is still positive, and then times a negative there gives us a negative. And just to check, with a 0, let's say over here, this is positive and this is positive, so we have a positive. And so what do we have here? We have a relative. We have a relative max. And it doesn't specifically ask us what that relative max is, but we could figure out what it is if we wanted to. It looks like it is 2 times 1 is 2, and then e to the negative 1 is just over e, so it's a relative max of 2 over e at x equals 1. Good or no? No, Aiden, you only need the x value and the fact that it says, the fact that it's a relative max. It doesn't ask, but just to, sometimes they will ask, so that's why I wanted to do it. All right, here is a nice little parametric, and this one is a calculator question, so you're allowed to use your calculator on this. So I got 3 different parts to this. They're giving you dx dt for a position function for this vector or this parametric. And we want to find the speed. And then we want to know if there's a time when it's furthest to the right. And if not, explain why. And then we want to know what happens to the path of the particle as t increases without bound. So I'll give you guys about 5 minutes or so to work on this one. That will hopefully be enough. I'll check back with you guys in just a minute. All right, so if we're looking for the speed of the particle at t equals 3, speed is the magnitude of your velocity vector, and we're given a position vector. So x of t, y of t, and then we're given the derivative of that. So if I were to write this out in component form, 6 over t minus 3 to the 1/3, comma t e to the negative t would be my velocity vector. And so we're looking for the magnitude of that velocity vector. So we're looking for the absolute value, t 6 over third, comma t e to the negative t. So that's what we're looking for. And we remember how to do that, hopefully, by, we're going to say this is at t equals 3, by plugging in that value of 3 and then using the Pythagorean theorem on our 2 pieces of it. So this becomes the absolute value of what vector? If I plug in 3 to that, this becomes 2 minus 3, so negative 1 to the 1/3. And what's the cube root of negative 1? Should be negative 1. Comma, plug in 3 to this, we have 3 e to the negative 3. Everybody good with that so far? You guys all get that? Start with it. So we should have the square root of negative 1 squared plus 3e to the negative 3 squared. And what did that come out to be? My guess is just very slightly above 1.011. Did everybody get 1.011 for that? Cool. Anybody have any issues with that part? All right. So the second part of this is we want to know if there's a t value at which the particle is farthest to the right. So first off, are there any endpoints to the interval we're given for this particular curve? There shouldn't be any endpoints, right? It just tells us that t is greater than 0. So we have a restriction on the t values, but no endpoints, right? There's no t greater than or equal to 0, so we don't need to take 0 into account. And we can't obviously take infinity into account. So the only thing we're interested in is critical values of the derivative of the x component of our position vector. And so the derivative of the x component of our position vector is 6 over t minus 3 to the 1/3. And we want to know if that's ever equal to 0 and if that's ever undefined. So first off, it equals 0 when 6 over t minus 3 equals 0. Which would give us what? T equals 2. And then what about undefined? It'd be undefined at only one value, t equals 0. But since t equals 0 is not included in our domain for our t values, we can ignore that, right? We can ignore it because t is greater than 0. Everybody good with that so far? All right, so then what we need to do is we need to figure out at t equals 2 if we are furthest to the right, or if we are furthest to the left, or if we are neither. And so keeping in mind that we're doing a sign chart for dx dt, which was 6 over t minus 3's cube root. Plug in something less than 2 but greater than 0, right? We don't want to go any lower than 0. So plug in something like 1. We got 6 over 1 is 6, minus 3 is a positive number, and the cube root of the positive is positive. So our particle is moving to the right from t equals 0 to t equals 2. And then as we go beyond 2, plug in something greater than 2, like 10 or 1,000 or whatever. This is a value that's less than 1. If we plug in 1,000, let's say, subtract 3, it's negative, and the cube root of a negative is negative, so we're moving to the left. So it would appear that there is a place where our particle is furthest to the right. Our particle is furthest right at t equals 2. Everybody good with that? Perfect. All right. So in the last part of it, what was the last thing it was asking us? It says, describe the behavior of the path of the particle as t increases without bound. So we're interested in what happens to the particle as t goes towards infinity, but all we're given is the derivative of x and the derivative of y with respect to t. So we're going to have to use that information and look at the limits as t approaches infinity. Was there another part to that other question? Somehow I must have not read the whole thing. If yes, explain why and give the value of, okay, sorry, I thought we just gave the value of t. Oh, and the x coordinate of the position of the particle. Yeah, okay, so we're not going to worry about the x coordinate of the position of the particle right now, because what does that require us to do at the moment? That should require us to use an integral, right? And since we haven't talked about integrals yet, we'll worry about that. We'll probably come back to this question sometime once we've talked about integrals. But yeah, you just integrate your dx dt value there using your initial condition of t equals 3, it being 5, 4 to find the constant when you integrate, and you'd end up with some x coordinate. So don't worry about that right now. We'll worry about that when we come back to vectors and parametric stuff after we've done integrals. So let's take a look at the limit as t approaches infinity of dx dt. So this is the limit as t approaches infinity of 6 over t minus 3 to the 1/3. And as t goes towards infinity, what is this approaching? Six over 2 minus 3 to the 1/3, yeah. It's definitely going towards a negative value, right? Because this is a -3. It's not negative infinity. It's just going towards -3 to the 1/3 value, or to the 1/3 root, to the 1/3 power, or the cube root of -3. So it's going which direction? As t goes towards infinity, we know the particle is moving left. So that's one thing we know about it, because that's a negative value, right? Dx dt is always negative as we go towards infinity. And what about the limit as t approaches infinity of dy dt? That's the limit as t approaches infinity of, what was it, t e to the negative t, I believe. And so as we approach infinity, this becomes what? What is that limit equal? Yeah, exactly. It should be 0, right? Should definitely be 0. And what does that tell us? If the change in the y values is approaching 0 as t goes towards infinity, what should our particle be doing? What should it be approaching? If the rate of change of y is effectively becoming 0. So right, at a constant position, that's almost right, Darius. It's not getting to be 0, right? We're approaching 0 for this rate of change. So if your rate of change of something is approaching 0, it should be approaching a horizontal asymptote, right? It's getting very close, Nick, to a flat line. And when we get very close to being a flat line, we're approaching a horizontal asymptote. So what we would say is that this particle is moving left towards a horizontal asymptote. Does that make sense or no? Any questions or issues with any part of that? All right, let's do another one. This one should be pretty straightforward. We're just looking for a second derivative for this parametric. So I'll give you guys just a minute or so to do that. Pretty straightforward one. Take just a minute and figure out the second derivative of y with respect to x. So first off, to find dy dx, we just need to do dy dt over dx dt. Dy dx is equal to dy dt over dx dt. So that will be 3t squared over 2t. Okay. And then if we want, we can simplify that right now to 3t over 2. And then we need to take the derivative of that and then divide it by dx dt. So it's the derivative with respect to t of 3t over 2 over dx dt. And so the derivative of 3t over 2 is just 3 halves divided by our dx dt, which is 2t, or 3 over 4t. Is that how you guys did it? Hopefully. Anybody not simplify this first? If you didn't simplify that first, you should still end up with the same thing, just with more simplification to do at the end. Any questions or issues there? All right, let's do another one. We're going to do a couple of these acceleration vector ones real quick. I wouldn't expect anything in the free response to be as easy as these acceleration vector ones. These all would have been multiple choice, except I just didn't give you the multiple choice questions on them. So I'll give you a minute or two, not too long, to do this one. All right, so we're given our position, a parametric for our position function. So the position vector should just be 4t plus t squared, comma 1 over 3t plus 1. This is our position vector. So what should our velocity vector be? Should just be the derivative of that, which should be what? 4 plus 2t. And what's the derivative of 1 over 3t plus 1? That's 3t plus 1 to the negative first power. We can use the reciprocal rule on it if we want. So what do we get? We get the derivative, we get the opposite of the derivative of 3t plus 1, which is 3 over 3t plus 1 squared. Is that what you all got for your velocity vector? Hopefully so. Okay. And then your acceleration vector, take your derivative of 4 plus 2t, which is just 2. And your derivative of this is negative 3 times 3t plus 1 to the negative 2. So we'll write it out over here. Negative 3t plus 1 to the negative 2. So that becomes a 6 times 3t plus 1 to the negative 3. So 6 over 3t plus 1 cubed, and then times the derivative of the 3t plus 1, so times 3. So hopefully you got that for your acceleration vector. And then at t equals 1, should have just got 2 comma, let's see, what does that become? That becomes a 4 cubed over there. So what's that? 18 over 64, which I think is just what, 9 over 32. Good or no? Any questions on that? All right, let's see, I wanted to do the polar one, but we're not gonna have time for that. We got a bunch of acceleration vector ones in here. You guys wanna do one more acceleration vector one and then call it a day? We're gonna do the polar one tomorrow, just because I wanna make sure we do the polar one, but we'll also get into the optimization. So one more acceleration vector, or you guys feel like you're good there? All right, I'll post up all of these problems. So actually what I'd like you to do, there should be, let's see, 1, 2, 3, 4 more vector ones. They're all just finding acceleration vectors, pretty straightforward. They like to ask that on the multiple choice. And then there's this one that's a polar one. So I'll post all these up in today's completed notes, just so you can see all the problems, so I can get this up beforehand. So try and do those between now and tomorrow. I don't think, see, I've got one assignment that's due today, right? So, and then another one that's due tomorrow. Is that right? I think that's what we got posted. So you shouldn't have too much to do. Today's assignment's pretty short anyway. So we'll call that good for today. And if you have any questions, feel free to hang around and ask. Otherwise, we'll see you guys tomorrow.